in the invisible world beneath our sight. A revolution is unfolding, not one of war or politics, but one that happens in silence, inside the smallest spaces of existence. Imagine a universe where atoms are no longer just particles but instruments, tools we can arrange to command matter itself. This is the realm of nanotechnology, a science so small it escapes the naked eye, yet so powerful it could redefine civilization. From the blood in our veins to the metal that shapes our cities, nanotechnology whispers of infinite potential. It could heal our bodies, rebuild our planet, and change what it means to be human. But like all great powers, it carries shadows. Because when humanity learns to write reality on the atomic scale, the line between science and magic begins to blur. And sometimes, the smallest inventions hold the greatest consequences. The story of nanotechnology begins not with machines, but with a dream. In 1959, physicist Richard Feynman stood before a crowd at Caltech and imagined a world where we could manipulate atoms one by one, a universe where construction began, not from the top down, but from the bottom up. "There's plenty of room at the bottom," he said, planting a seed in the minds of future scientists. Decades later, his words became prophecy. With the invention of the scanning tunneling microscope in 1981, humanity could finally see and move individual atoms. It was like inventing a paintbrush that could paint with the stars themselves. And so began the quiet revolution. From imagination to manipulation, we crossed the threshold. We were no longer just observers of the microscopic. We had become its architects. To grasp the power of nanotechnology, you must first understand its scale. A nanometer is 1/1,000,000th of a meter, smaller than a virus, smaller than the wavelength of light. At this scale, the laws of physics begin to twist in ways that defy intuition. Gold, for instance, ceases to be gold. It glows red or purple. Carbon, arranged one way, is soft graphite, yet rearrange its atoms, and it becomes diamond, unbreakable, and brilliant. But in yet another atomic pattern, it becomes graphene, a sheet of carbon 1 atom thick, 200 times stronger than steel, and so conductive it could revolutionize energy. This is the promise of the nanoscale. Matter itself becomes programmable, and when matter is programmable, reality itself becomes editable. Humanity had just discovered the smallest keyboard to rewrite existence. The 1990s marked the true awakening. Scientists began uncovering carbon nanotubes, quantum dots, and molecular machines, devices so small they could fit inside a cell. Yet few outside the labs noticed. It wasn't the flashy kind of science. There were no rockets or explosions, only quiet discoveries hidden in sterile rooms. But while the world was distracted, nanotechnology crept into our daily lives. Sunscreens began using nanoparticles to block UV rays more efficiently. Fabrics gained resistance to stains in water. Batteries became smaller, lighter, and stronger. Even the chips inside your phone owe their existence to nanoscale engineering. The revolution didn't roar, it whispered. And by the time humanity realized it, nanotechnology wasn't a concept anymore. It was already living inside the ordinary, reshaping the world molecule by molecule. At its Earth, nanotechnology is the mastery of construction at the level where matter itself begins. Engineers use two primary methods, bottom-up and top-down. In the bottom-up approach, molecules self-assemble like puzzle pieces, guided by natural forces of chemistry and physics. In the top-down approach, materials are carved and etched using lasers or electron beams, sculpted with precision beyond imagination. Think of it as architecture for atoms. Every bond, every particle, placed deliberately. Through this, scientists create metals that remember their shapes, glass that heals cracks on its own, and coatings that repel dirt or radiation. At this level, we aren't just designing materials, we're redesigning their essence. Humanity has crossed from using nature's laws to rewriting them. What was once the domain of gods and myth now sits under a microscope, humming softly in the hands of engineers. Nowhere does nanotechnology feel more miraculous than inside the human body. Picture this: millions of tiny machines, invisible to the eye, coursing through your bloodstream. They find and destroy cancer cells one by one, repair tissue at the molecular level, or deliver medicine precisely where it's needed. It sounds like science fiction, yet it's already being tested in labs around the world. Researchers have built nanoparticles that recognize the molecular signature of tumors, attach the tumor and release drugs only at the target site. Imagine curing disease, not through massive doses of chemicals, but through microscopic precision. Imagine medicine that knows exactly where to go and what to do. For centuries, we've treated illness from the outside. Now, For the first time, we can heal from within, turning the human body into its own repair system. In 2023, a breakthrough at MIT changed everything. Scientists developed a nanoparticle capable of crossing the blood-brain barrier, something once thought impossible. This barrier protects our brain from most substances, but it also makes treating neurological diseases nearly impossible. Until now. Now, these nanoparticles carried therapeutic molecules directly into the brain, targeting tumors with stunning accuracy. In early trials, the results were astonishing. Tumors began to shrink, and patients who once had no options found hope again. Elsewhere, researchers engineered nanobots, controlled by magnetic fields, guiding them through blood vessels to clear arterial blockages. They could repair tissues, deliver genetic instructions, even detect infection in real time. The stuff of fantasy had become fact. Humanity had learned to send machines smaller than cells into the body and command them like an army of healers. But every creation casts a shadow. The same technology that heals could also harm. The same self-replicating systems that Bill could consume. Scientists call it the gray goo scenario, a hypothetical nightmare where self-replicating nanomachines spiral out of control, converting all matter into more of themselves. While this remains speculative, it embodies a real fear. Loss of control. Nanoparticles already slip through our lungs, our blood, and into ecosystems, and we still don't fully understand their long-term impact. They don't biodegrade, they move in ways we can't yet track. Nanotechnology has the power to reshape biology, materials, and the environment itself. And with that power comes responsibility. For every miracle discovered in the lab, there's an echo of danger waiting in its reflection. Because the smaller our creations become, the larger their consequences can grow. And yet, in that razor-thin space, between fear and hope, nanotechnology might be our salvation. As the planet strains under the weight of climate change, researchers are developing nanomaterials to capture carbon directly from the air, split water to create clean hydrogen, and build solar panels that absorb nearly every photon of sunlight. Imagine batteries that recharge in seconds and last for decades, powered by graphene and quantum nanostructures. Nanofilters already exist that can purify seawater into drinkable water within minutes. A gift for the billions who through these microscopic miracles, we may finally achieve what centuries of industry could not: harmony between human progress and the planet that sustains us. The dream of clean, endless energy is no longer poetic idealism. It's an engineering blueprint, being drawn one atom at a time. But the invisible revolution isn't confined to laboratories or distant industries. It is already here, in your pocket, your clothes, your home. The anti-scratch coating on your phone screen. Nanotechnology, the water-resistant layer on your jacket. Nanotechnology. Even the packaging that keeps your food fresh longer relies on nanoscale coatings. These invisible systems work silently, unnoticed, they've become so integrated into our lives that we forget to marvel at them. Humanity has reached a strange point, surrounded by miracles we no longer see. The world has changed beneath our fingertips. And yet, because the revolution is microscopic, it feels almost unreal. But every time you touch your screen or breathe clean air through a nanofilter, remember, you're already living in the future Feynman once only dreamed of. Of course, where there's innovation, there's ambition. Governments around the world are racing to militarize nanotechnology, to build armor that repairs itself. Fabrics that sense wounds and administer medication, and drones so small they can slip through cracks in a wall. Nanoweapons that can alter materials mid-flight, or nanobots that can disable electronics on command. These ideas are not distant hypotheticals anymore. They're prototypes. Billions of dollars are being funneled into what's now called nano-warfare. The battlefield of the future will not be fought with tanks and missiles, but with invisible machines, swarms smaller than dust, capable of dismantling infrastructure or infiltrating networks undetected. Humanity has always turned progress into power. And now, as we learn to control the smallest scales of matter, the definition of power itself is shrinking. And so we arrive at a deeper question, one not of science, but of meaning. Nanotechnology isn't just about manipulating atoms. It's about redefining creation itself. For the first time in history, humans aren't just observers of nature. We're becoming its editors. We no longer merely use the laws of physics. We rewrite them. We're approaching a threshold where life can be designed, molecule by molecule, as easily as software. And in that lies an existential tension. When we can design matter, What becomes of mystery? When we can craft biology, what becomes of faith? The deeper we go into the nanoscale, the more we resemble the myths of our ancestors' creators, shaping life from dust. We are, perhaps unknowingly, stepping into the role of gods, armed not with lightning, but with microscopes. But maybe that's what it has always meant to be human, to push the boundary of the possible. Every age of progress began with awe and ended with reflection. Fire brought warmth and war. The atom brought energy and annihilation. Now, the nanoscale brings both the potential to heal and to harm. And yet, through all of this, one thing remains constant: the yearning to understand, to connect, to create. We chase control over the universe, not out of arrogance, but out of longing. The same longing that built art, music, and love. We want to belong within the grand machinery of existence, not above it, to speak the language of matter, not to dominate it, but to be part of its harmony. Nanotechnology, at its heart, isn't just science. It's a love letter to understanding creation itself. So where is this all leading us? Picture cities built atom by atom, structures that heal their own cracks, and roads that generate their own energy. Imagine food engineered to perfection, grown without waste, customized to your biology, diseases detected before symptoms ever appear, and treatments that unfold from within. In the next few decades, we could witness an era where biology, chemistry, and computing merge into one seamless system. A world where design replaces discovery. This is the invisible future, silent, unseen, inevitable. The power to rebuild our world, hidden in the smallest corners of reality. Humanity has always looked to the stars for answers, but the next great frontier isn't above us. It's beneath us, inside the dust, the atoms, the spaces between, the frontier of the infinitely small. In the end, nanotechnology isn't just a tool, it's a mere reflecting who we are and what we might become. It shows us our brilliance and our hubris, our compassion and our carelessness. Every atom we move carries a moral weight, every molecule a question about our future. We stand at the edge of an invisible revolution, holding power beyond comprehension. The power to create, to heal, to destroy. But maybe the true miracle isn't in what we can build. It's in the choice of how we build it. For within the smallest things, we find the grandest truths, that the universe, in all its vastness, can be rewritten by hands that understand its tiniest whispers. And maybe, just maybe, the story of our future won't be written in the stars, but in the spaces between them.